Hello, my name is Daniel, and today we will be going through the 2009 AMC 10B together. So let's get started. First problem, each morning of her 5-day work week, Jane bought either a 50-cent muffin or a 75-cent bagel. Her total cost for the week was a whole number of dollars. How many bagels did she buy? Okay, so her total cost was a whole number of dollars. So she bought an odd number of 50-cent muffins and an even number of 75-cent bagels. And so and they have to sum to 5 because her 5-day work week and it's each morning. So this could be 2 and 3 or 4 and 1. If it's 4 and 1, then this would be 75 times 4, so it's 2,350 cents. That's not a whole dollar amount, so this is wrong. And so this would be right. So 2 bagels would be 150 cents plus 50 cent muffins times 3. That would be 150. This is 300 cents. So it's a whole number of dollars. So she bought 2 bagels. The answer is B. Number 2, which of the following is equal to 1/3 minus 1/4 over 1/2 minus 1/3? This is minus 1/4 over 1/2 minus 1/3. Multiply the numerator and the denominator by 12. This is 4 minus 3 over 6 minus 4 equals 1 over 2. So the answer is C. Problem 3, Paula the painter just enough paint for 30 identical sized rooms. And on the way to work, 3 cans of paint fell off her truck, so she had only enough paint for 25 rooms. Okay, so 3 cans falling off equals 5 rooms less, right? So 3 cans is 5 rooms. And then she used for the 25 rooms, right? So 25 rooms must be multiplied by 5, right? So 15 cans. The answer is C. Number 4, a rectangular yard contains 2 flower beds in the shape of congruent isosceles right triangles. The remainder of the yard has a trapezoidal shape as shown. The parallel sides have length 15 and 25 meters, so this would be 15, this would be 25. So this would be 5 and 5, and since it's isosceles right triangles, this would be 5 and 5. So the the area of the yard would be 5 times 25, and then flower beds would be 5 times 5, so this would be 1 over 5. The answer is C. Number 5, 20% less than 60 is 1/3 more than what number? Okay, so 20% less equals 80% of 60, so 80% percent of 60 equals 48 equals 1/3 more, so it's 4/3 of 36, so the number is 36. The answer is D. Number 6, Kiana has 2 older twin brothers. The product of their 3 ages is 128, whereas the sum of their 3 ages. Okay, so 128 is 2 to the 7th power, and older twin brothers, this means that this could only be 2 times 2 to the 3rd power times 2 to the 3rd power. So the 3 ages are 2 plus 8 plus 8 equals 18. The answer is D. Number 7, by inserting parentheses, it is possible to give the expression 2 times 3 plus 4 times 5 several values. How many different values can be obtained? So if we just do it like this, then this will be 6 plus 20, so this will be 26. If we put the parentheses like this, then that would be 6 plus 4, so it's 10. 10 times 5, it's 50. And then if we put something like this, then 10 times 7, so it will be 70. And if we put like the and then if we put like this, then it will be 23 times 2, so it would be 46. So there are 4 different values. The answer is C. Number 8. In a certain year, the price of gasoline rose by 20% during January, fell by 20% during February, rose by 25% during March, and fell by X% during April. The price of gasoline at the end of April was the same as it had been at the beginning of January. So if it was X at the beginning of, let's say it was A at the beginning of January, and it rose by 20%, so times 6 over 5, and then fell by 20%, so 4 over 5, and then rose by 25%, so 5 over 4, and then fell by X%, so, and then this equals A, right? So for it to equal A, these two cancel, right? So this would have to be 5 over 6. So X% is 5 over 6. So x equals 500 over 6. So 500 divided by 6 would be 848, 23, 18. So 83.333. So so x is not actually 500 over 6. And so it became, price became 83%, about 83%. So it went down 17%, right? And x is how much it fell, right? So the answer is 17%. The answer is B. Number 9, BD and AE intersect at C as shown. AB equals BE equals CD equals CE, and A is 5 over 2 times B. What is the degree measure of D? Okay, so these are the same. Sorry, I don't know what's happening here. Yeah, that's better. So here A is 5 over 2B, right? So this is 5, this is 5, this is 2, and then we would be able to know what each of these are because the sum would be 180, right? So 12 times something would be 180, so something would be 1 and then 5, so 15. So 15 times 2 is 30, 15 times 5 is 75, 15 times 5 is also 75, and so the degree measure of D, this would be 75, D would be 180 minus 75 over 2, this is 105 over 2, and then this is 52.5, so the answer is A. Number 10, a flagpole is originally 5 meters tall. A hurricane snaps the flagpole at a point x meters above the ground so that the upper part still attached to the stump touches the ground 1 meter away from the base. What is x? Okay, so the flagpole is 5 meters tall, but it broke, so it's like this. And it touches the ground 1 meter away, right? So this is 1 meter. And let's say that this, and the point x meters above the ground, right? So this will be x. And since this much was the whole flagpole, and that was 5 meters, this would be 5 minus x. So 5 minus x squared equals x squared plus 1 squared. So 25 minus 10x equals 1. 10x equals 24. X equals 2.4. So the answer is E. Number 11. How many 7-digit palindromes, numbers that read the same backward as forward, can be formed using the digits 2, 2, 3, 3, 5, 5, 5? So the primary thing to note here is that there are 3 5s, so that means that the 5 must be in the middle, and then there should be 3 and 3, and these should be like and they should be the same forwards and backwards. So the numbers 2, 3, or 5 could come in here in any random order, and so this would be 3 factorial equals 6. So the answer is 6 palindromes. The answer is A. Number 12, distinct points A, B, C, and D lie on a line with AB equals BC equals CD equals 1. So there's A, B, C, and D, and they all equal 1, right? 1, 1, 1. E and F lie on a second line parallel to the first with EF equals 1. So let's say that this is EF, this is 1. And so a triangle with positive area has 3 of the 6 points as vertices. How many possible values are there for the area of the triangle? Okay, so the height will always be the same. So what's different would be the length of the base, right? So it could be base 1 or base 2, or it could be base 3, and that's all of the areas that, and that's all the different areas that this triangle can provide. So there are 3. The answer is A. Number 13, as shown below, convex pentagon ABCDE has sides AB is 3, BC is 4, CD is 6, DE is 3, and EA is 7. The pentagon is positioned like this, with vertex A with vertex A at the origin and B on the positive x-axis. So it's going to be rolling this way, right along the x-axis, which side will touch the point x equals 2009 on the x-axis. Okay, so let's first find out the perimeter of this shape. Perimeter is 3 plus 4 plus 6 plus 3 plus 7, which is 23. So the perimeter is 23. The perimeter, perimeter equals 23. And which side will touch the point x equals 2009? Okay, so we're starting from 0, 0, and so we have to divide 2009 by 23. So to see how many like revolutions that would make and how many points would be left. So this would be what is it? 4, 12, 92, 89. So this is 7. No. This is 3, 4, 3. 969. 4 times 3, 12. Yeah, this was wrong from the first place. It's not 43, so it's a 200, right? So we have to treat it like a 200. So this would be like 8, probably 24, 16, 184, 23. Yes, this makes sense. So it's 184, so it's 169. So it's 7, 161. The remainder is 8. Is 8. So in 87 rotations, it's going to end up back right in this position, and then x equals 2009 would be just about here, and then this would be a length of 8. So so from that length of 8, 3 will be taken up by AB, and then 4 will be taken up by BC, and then there's 1 left, and that will be right here, and so that point is on CD. The answer is C. Number 14. On one day, Millie puts a quart of seeds, 25% of which are millet, into a bird feeder. On each successive day, she adds another quart of the same mix of seeds without removing any seeds that are left. Each day, the birds eat only 25% of the millet in the feeder, but they eat all of the other seeds. On which day, just after Millie has placed the seeds, will the birds find that more than half the seeds in the feeder are millet? Okay, so first of all, you see these 25% coming out here, and we know that these are 1/4, 1/4, and so we can think that like numbers are constantly going to be divided by 4, right? And so what we wanted to do when setting the initial value for the seeds would be it would be like not a multiple. It would be like 4 to some nth power, and to a high power, because that would make less fractions, right? So let's just say it's 256, 256, which is 4 to the 4th power, I believe. Yes, it is. So on which day, just after Millie has placed the seeds, will the birds find that more than half of the seeds in the feeder are millet? Okay, so first of all, 25% of the seeds are millet, right? So out of the 256, 64 are millet, and 192 are other seeds. Okay, so the amount of millet has to be greater than 192 for the first time, and that's when we get our answer, right? And so since we get 64 millets in the first place, so we'll start out with 64, and then it says each day the birds eat only 25% of the millet in the feeder, right? So if we multiply, so 64 times 3/4, because that's 75%. This would equal 48. And then the next day, right? And then this is the next day. So Millie would put more 64 more seeds, and then that was summed to 112. And then the birds will eat 25% of that, so what's left will be 75% of that. So this times 3/4 would be 84, and then we add 64 again because it's the next day, and then the sum is 148, and then multiply this by 3/4. 148 times 3/4 would be 27321. 2 times 3 is 980. No, 1, it's not 27. For 3, yeah, it's 37 times 3, 21. So it's 111, 111, and then more 64. This would be 175, and then we would have to get 3 over 4 of this. 175 times 3 over 4, so times 3 would be 15, 22, and then 525 divided by 4 equals 131.25, right? Since it's 131 and 1/4, so this would be 131.25, and then add 64 more. This becomes 195.25, and this is finally greater than 192. So this is Monday, Tuesday, Wednesday, Thursday, Friday. So the answer is Friday. It's D. Number 15. When a bucket is 2/3 full of water, the bucket and water weigh 8 kilograms. When the bucket is 1/2 full of water, the total weight is B kilograms. In terms of A and B, what is the total weight in kilograms when the bucket is full of water? Okay, so let's say that the bucket is 2/3 full of water. 2/3 full. Yeah, so 2/3 full would be A, and then half full, 1/2. This would be B. So if we subtract these, then B minus A would equal to, no, not B minus A. A minus B would equal to, this is 4/6, 3/6. So this would equal to 1/6 of the water. And so full water would equal to this times 6, right? So it's 6A minus 6B. No, it's 3 times A minus B, right? Yeah. It's 6A minus B. And then the total weight in kilograms when the bucket is full of water. Okay, so the weight of the bucket would be, so when it's half full, so the half full plus the bucket is B, right? So bucket is B minus half full, so half full would be 3 of these, 3 of A minus B, and then we would need to add 6A minus B, so plus 6A minus B. This will be B minus 3, so this would be B plus 3A minus B, which is B plus 3A minus 3B. This is 3A minus 2B, so the answer is E. Number 16, points A and C lie on a circle centered at 0. Each of B, A, and BC are tangent to the circle, and ABC is equilateral. The circle intersects BO at D. What is BO over BD? No, what is BD over BO, right? Since this triangle is equilateral, we can see that this is 60, this is 60, therefore this is 30, and this is 30. And since this is similar to this, this is also 60 and 30. And so therefore we can say that since the ratio of this to this would be 1 to 2. Let's put it in blue. 1 to 2, and then 2 is the same as here, right? So this would also be 1. This would be 1. And then this would also be 2. So BD over BO is, BD is 2, BO is 2 plus 1 plus 1, which is 4. So BD over BO is 2 over 4, which is 1 over 2. The answer is B. 17. 5 unit squares are arranged in the coordinate plane as shown, like this, in a W kind of shape, with the lower left corner at the origin. The slanted line extending from C, 0 to 3, 3 divides the entire region into 2 regions of equal area. What is C? Okay, so it says it's 2 regions of equal area, which means that this area will be half of 5. So half of 5, so this is 5 over 2, right? 5 over 2. And then if we add one more square here, like that, plus, then it would be plus 1, right? So this is 7 over 2. 7 over 2. But then, since this is 3 and this is 3 minus 7, no, this is 3 minus C, this would be the same as the area of the triangle, right? So 1/2 times 3 minus C. And so so multiply by 2, and then 7 over 3 will be equal to 3 minus c. C equals 3 minus 7 over 3. This is 2 over 3. So the answer is C. And number 18, rectangle ABCD has AB equals 8 and BC equals 6. Point M is the midpoint of diagonal AC and E is on AB. With ME is perpendicular to AC, what is the area of AME? Okay, so let's draw this first. There's a rectangle ABCD, not a square, a rectangle, like that, with AB equals ABCD, AB equals 8 and BC equals 6. M is the midpoint of diagonal AC, so let's have a diagonal AC, and then M is the midpoint of that. This would be M. E is on AB, with ME is perpendicular to AC. Okay, so E would be like this, right? And then this would be perpendicular. So by Pythagoras first, since this is 8 and this is 6, this whole thing will be 10. And since M is the midpoint, this will be 5. And since this triangle and this triangle would be similar, let's say that this point is F. So ABC and AMF are similar, right? So to get MF equals 3 over 4 multiplied by 5. So this is 15 over 4, right? So the area of AME is, oh yeah, this is E, right? This is E. So AME is similar. I don't know, I didn't notice that. So this is actually E. And what's the area of AME? So it's this area. So what we want is 5 times ME is 15 over 4 times 1/2, because it's a triangle. This equals 75 over 8. The answer is D. Problem 19. A particular 10-hour digital clock displays the hour and minute of the day. Unfortunately, whenever it's supposed to display a 1, it mistakenly displays 9. What fraction of the day will the clock show the correct time? Okay, so the correct time would be when it is not showing, so when it doesn't have a 1, not supposed to have a 1. So the hours could be, since 1 is gone, and 2, 3, 4, 5, 6, 7, 8, 9, and then 10, 11, 12 can't be used because there is a 1 in them. And then the minutes would be 0, 1, and then so it's not 0, 1, and then 21, 31, 41, 51, and 10 to 19. So this is 60 minus 5 minus 10. This is 45. And so 2, 3, 4, 5, 6, 7, 8, 9, these are 8 numbers, and these are 45 numbers. So what fraction of the day will the clock show the correct time? So it's 8 times 45 over 12 times 60. So this becomes 3 over 4. This becomes 2 over 3. These two cancel. These two also cancel as 2. This is 1 over 2, so the answer is A. Problem 20. Triangle ABC has a right angle at B. AB equals 1. BC equals 2. The angle bisector of A intersects side BC at D. What is BD? Okay, so since BC is 2, and then by Pythagoras we can know that this is 2. No, we can know that this is root 5. And then since this is an angle bisector, so this and this angles are the same, we can know that the BD to DC ratio is the same as AB to AC. So this will be x, and this will be root 5x, but the whole thing is 2, right? So x plus root 5x equals 2. X equals 2 over root 5 plus 1. This equals 2 over 5 minus 1. And then this times root 5 minus 1. So this will be root 5 minus 1 over 2. So it's B. Problem 21. What is the remainder when 3 to the 0th power plus 3 to the first power plus 3 squared all the way to 3 to the 2009th power is divided by 8? Okay, so 3 to the 0th power is 1, and then it's 3, 9, 27, 81, 243, all the way on. But then let's divide these by 8. So if we divide these by 8, then the remainder is 1, 3, 1, 3, 1, 3. Okay, so we can notice that it's an ongoing pattern of 1, 3, 1, 3, 1, 3 over and over again. So if this is divided by 8, there are 2010 numbers. So there will be 1005 pairs of these two of 4, right? So this is 1005 times 4, and so this is 4020, and so the remainder when 4020 is divided by 8, 4020 divided by 8 equals 502 with a remainder of 4, right? So the answer is D, since it's 4. Number 22, a cubical cake with edge length 2 inches is iced on the sides and the top. It is cut vertically into 3 pieces as shown in this top view. M is the midpoint of a top edge. Okay, so M is the midpoint, so this would be 1, this would be 2, and so this would be root 5. The piece whose top is triangle B contains C cubic inches of C cake and S square inches of icing. Let's erase this, and then since this triangle and this triangle are similar, and we know that this is 2, so and this is root 5, right? So B, so the triangle B could be like this. This is 2, and then this is root 2 times 2 over root 5. This will be 2 times 1 over root 5. So this is 2 over root 5 times 4 over root 5. This is 4 over 5. So the answer is 4 over 5, and triangle B contains C cubic inches of cake. So cake would be the volume. So 4 over 5 times, so it's 4 over 5 multiplied by edge length 2 inches, and then it's a cubical cake, so this is times 2, and then icing would be this much, and then it's on the sides also, right? So we have to put in one more side. So this is 2 times 2, so cake plus icing equals 8 over 5 plus 4 over 5 plus 20 over 5, right? So this is 12 plus 20 over 5. This is 32 over 5. So the answer is B. Problem number 23. Rachel and Robert run on a circular track. Rachel runs counterclockwise and completes a lap every 90 seconds, and Robert runs clockwise and completes a lap every 80 seconds. Both start from the same line at the same time at some random time between 10 minutes and 11 minutes after they begin to run. A photographer standing inside the track takes a picture that shows 1/4 of the track centered on the starting line. What is the probability that both Rachel and Robert are in the picture? Okay, so there's a circular track, right? And then there's a circular track, and then Rachel. So let's say they start from here. Rachel runs counterclockwise, and then Robert runs clockwise. So let's start with Rachel. Rachel completes 1 lap in every 90 seconds, right? So let's multiply this by 2. 2 laps in 180 seconds. So this means that she completes 2 laps in 3 minutes, right? And so let's get close to this 10 minutes, right? So 9 minutes have passed. She will have ran a complete 6 laps. So this must mean that she is back at the starting point, right? And then 1 more minute passes, 10 minutes. This would be 1 lap every 90 seconds. So 90 times 2 over 3 is 60, right? 60 seconds. So 60 seconds will be 2 over 3 of the whole track. 2 over 3 of the whole track. And then 11 minutes will be 2 over 3 more, right? So this is 2 over 3 more. This is 1 over 3. And so if you draw Rachel's kind of progress progress in the time between 10 minutes and 11 minutes, it will be like this. So if there is a center, and this is 120 degrees and this is 120 degrees, she would have ran from the 2/3 line to the 1/3 line, so like this all the way to here. This is what Rachel would have run. And then we have Robert, right? Robert, so he runs one lap in every 80 seconds, right? So let's multiply this by 3. So 3 laps every 240 seconds. So he runs 3 laps in 4 minutes. Similarly, let's try to get close to as 10 minutes as possible. So he runs 6 laps in 8 minutes. So 8 minutes is when he is back at his starting position. And then when 10 minutes comes, 2 minutes have passed, right? So 80 seconds is 1 lap, and then 40 seconds is half lap, right? So 120 seconds would be 3/2 laps. So this is 1 plus 1/2 lap. So 10 minutes he would be at the half line. Would be at the half line. So it's 1/2. And then at 11 minutes he will have traveled 3/4 more, right? So he will have traveled 3/4 more. So if we draw him, then if we draw his progress, then it would be like this, and then he would have come from the half line. Okay, so we're all assuming that they're starting at this point, right? Okay, so he's running clockwise, right? So he's running 3/4 more. So he's running like this. This is how he's running. Robert is running. What is the probability that both Rachel and Robert are in the picture, right? But then, so a photographer standing inside the track takes a picture that shows 1/4 of the track centered on the starting line, right? So let's erase all this since we are done with them. And then let's move these up here. Make them a little bigger. Yes. Oops. Yeah, so this one too. Right, okay, so the center is here, and since it's center on the starting line and it's 1/4 of the track, then it would probably be taking this much of the picture, so in this region, right? And so here too, like this, in this region. And so this for Robert, so the calculation will be pretty easy since he's going for 1 minute like this, and then if you divide this like that, there are 6 pieces of 6 pieces of track that he could have run. So each piece would have taken 10 seconds, since 1 minute is 60 seconds, right? So this is 10 seconds, 20 seconds, 30 seconds, 40 seconds, 50 seconds, and 60 seconds. So this much he would have been in from 30 seconds to 50 seconds. So like Robert could have been in the picture if the picture had been taken from the 30-second line to the 50-second line, right? And then Rachel, this is a bit more trickier since we're dealing with 120 degrees, and then we like suddenly have 45 degrees, right? And so since this is 120 degrees and this is also 120 degrees, then this angle would be 75 degrees, right? So the total is 240 degrees. So total is 240 degrees. 240 degrees, and then 75 degrees of that, and then multiply it by 60 seconds, because this is the number, because this is the specific seconds that Rachel could have been in the frame, in the picture frame. So this is 75 over 4. This is 18.75, and then when she ends, this is 75 plus 90, right? So the whole thing would have been 165, right? So 165 over 240 times 60, this will be 165 over 4 will be 41.25. So this is 18.75 seconds all the way to 41.25 seconds, right? But the photographer wanted both Rachel and Robert in the picture, right? So the only possible like overlap region could have been from 30 seconds to 41.25 seconds, right? So 41.25 minus 30 seconds would be 11.25 seconds, right? But then there are a total of 60s, but then this is out of a total of 60 seconds, so 11.25 out of 60. This would be 11 times 4, 44 plus 1, 45 over 60 times 4. This is 3 over 4 times 4. This is 3 over 16. So it's 3 over 16. The answer is C. And problem number 24. The keystone arch is an ancient architectural feature. It is composed of congruent isosceles trapezoids fitted together along the non-parallel sides as shown. The bottom sides of the two end trapezoids are horizontal in an arch made with 9 trapezoids. Let x be the angle measured in degrees of the larger interior angle of the trapezoid. What is x? Okay, so first let's draw everything like this, this, like this. So all these isosceles trapezoids, if they're connected well enough, then they will be all like matched on this one point at the center, and it would all be triangles like you're seeing right now. So this 180 degrees would be evenly divided into 1, 2, 3, 4, 5, 6, 7, 8, 9 points, right? So one triangle, so this would have 20 degrees, right? Because it's 180 divided by 9. And so since this is 20 degrees, this much would be 180 minus, so that would be 180 minus 20 over 2. This is 80 degrees. No, this is not 80. Yeah, this is 80 degrees, right? So this is 80. And so the larger interior angle, so what we want is this angle right here. So this is 100 minus 80 equals, no, this is 180 minus 80 equals 100 degrees, right? So the answer is 100, so it's A. And our last problem for today, each face of a cube is given a single narrow stripe painted from the center of one edge to the center of the opposite edge. The choice of the edge pairing is made at random and independently for each face. What is the probability that there is a continuous stripe encircling this cube? Okay, so let's make a cube first, like this. And then, so what it's saying is that for every face, it can have two choices, right? So it can either be like this, or the line can be like this. So there are two choices for every face. So this would be 2 to the 6th power, right? So the total number of possibilities is 2 to the 6th power. That will be the denominator, but there is but the probability that we need to choose that there is a continuous stripe encircling the cube, right? So a stripe needs to be encircling the whole cube. So it could be either this, or it could be this, or it could be this. So there are 3 possible ways to encircle, right? So there are 3 ways to encircle, and then when we are saying that like it's this one, then it doesn't matter what form that the stripe takes on this face and on this face, right? And so that will leave two choices. So that will leave 2 to the second power, and this would be 3 over 2 to the fourth power. This would be 3 over 16, and the answer is B. Okay, so that was problem 25 of the 2009 AMC 10B, and thank you for watching.